In this video we will integrate e to the power ax sine bx with respect to x. So in order to integrate this function we will use integration by parts. So the formula of integration by part is integral of u dv is equal to uv minus integral of v du. Now we have to suppose that what is u and what is dv in this integral. So we can suppose that u is equal to e to the power ax and dv is equal to sine bx dx. So we can suppose dv is equal to sine bx dx. Now we will take the differential du, which is equal to the derivative of e to the power ax, and the derivative of e to the power ax is a times e to the power ax, and here we will integrate both sides. So the integral of dv is v and the integral of sine bx is minus cos bx upon b, where this b is the derivative of the angle bx. Now we will put the value of u, v and v du in this integral. So the above integral will become integral of u, which is e to the power ax, then dv is sine bx dx, and this is the question. And then we will put the value of u, which is e to the power ax, and the value of v, which is minus cos bx upon b minus integral of v du. So the value of v is minus cos bx upon b, and the value of du is a times e to the power ax dx. A times e to the power ax dx. Now this will become minus e to the power ax cos bx upon b, and after simplifying this expression we have minus minus plus a upon b, because these are the constant and we can write it in front of the integral. So we have plus a upon b integral of e to the power ax cos bx dx. Now again we have two different functions in the integral, so we will use integration by parts again. So first of all, consider we have to integrate e to the power ax cos bx dx, and then let u is equal to e to the power ax and dv is equal to cos bx dx. Now the differential du is equal to e to the power ax, a times e to the power ex, and multiply by dx, and v is equal to the derivative of cos bx, which is sine bx upon b. Now by integration by parts we have integral of e to the power ax cos bx dx is equal to uv e to the power ax multiply by sine bx upon b minus integral of v du. So sine bx upon b multiply by a times e to the power ax dx. Now the integral of e to the power ax cos bx is equal to e to the power ax sine bx upon b minus a upon b times integral of e to the power ax sine bx dx. Now we will put the value of this integral in the above integral over here. So we have integral of e to the power ax sine bx dx is equal to minus e to the power ax cos bx upon b plus a upon b, and we will put the value of this integral in place of integral of e to the power ax cos bx dx. So we have e to the power ax sine bx upon b minus a upon b integral of e to the power ax sine bx dx. Now we will expand this bracket. So we have integral of e to the power ax sine bx dx minus is equal to minus e to the power ax cos bx upon b, then plus a times e to the power ax sine bx upon b multiplied by b is b square, and then plus a upon b multiplied by this factor, so we have minus a square upon b square integral of e to the power ax sine bx dx. Now we can take this integral on the other side of the equation. So we will have integral of e to the power ax sine bx dx plus a square upon b square integral of e to the power ax sine bx dx is equal to minus e to the power ax cos bx upon b plus a times e to the power ax sine bx upon b square. Now here we can see that the coefficient of this integral is 1 and the coefficient of this integral is a square upon b square, and because these integrals are same, so we can add the coefficient. So we have 1 plus a square upon b square multiplied by integral of e to the power ax sine bx dx is equal to, and over here we can write a times e to the power ax sine bx upon b square minus e to the power ax cos bx upon b. Now we can multiply this factor by b and also divide it by b, so we have b square in the denominator, and then here we will simplify these fractions. So we have b square plus a square upon b square multiplied by integral of e to the power ax sine bx dx, and here since the denominators are same, so we can add the numerator. So we have b square in the denominator, and in the numerator we can write a times e to the power ax sine bx minus b times e to the power ax cos bx. And now we can take this factor on the other side, so we will take the reciprocal of this factor, that is b square plus a square upon b square will become b square upon b square plus a square multiplied by this factor, and here we can take e to the power ax common, so we have a times sine bx minus b times cos bx in the bracket and then b square in the denominator. Now we can cancel b square and b square. So the integral of e to the power ax sine bx dx is equal to e to the power ax upon b square plus a square, and we can apply commutative law over here. So this can be written as a square plus b square, because a square plus b square is equal to b square plus a square, and then multiply it by a times sine bx minus b times cos bx, and then because this is the indefinite integral, so we will add the constant c. So the integral of e to the power ax sine bx with respect to x is equal to e to the power ax upon a square plus b square multiplied by a times sine bx minus b times cos bx plus c, where c is the constant of integration.